Reflect the quadrilateral and write the coordinate of the image. Coordinate of the image? It should be coordinates of the image. If you remember or don't remember, a shape before it's moved is called a pre-image. A shape after it's moved is called the image. If I wanted to reflect this, over the x-axis. There's the directions. If I wanted to reflect it over the x-axis, what I do is I like to draw the line on the x-axis. We did this in chapter 1, maybe? Maybe chapter 1? I don't know. What you do is you're going to take each point, count how many spaces it is away from your mirror. 1, 2, 3. And then count again. 1, 2, 3. And then put a dot there. And that's going to be my A prime. Remember, when we make an image, we put primes. D is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. D prime. Hey, someone call me when Optimus Prime shows up. Am I right, guys? M. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is M prime. These letters unscramble to make the word mad. W is 4 away, so W is going to be right here. And as you see, we have two congruent shapes. Congruent, of course, meaning they're the exact same shape, the exact same size. This one's just a mirror image. And since I know how to draw perfect straight lines on this Chromebook, you could see that it's a perfect mirror image. That is a reflection. You're welcome. Now, easy peasy, and chapter 3 is going to talk a little bit more about these transformations, but more from a crazier geometry sense. When the Netflix acts, if you're still watching and you see your reflection in the blank screen, that's cute. That's humorous. That happens to all of us sometimes. We watch TV and then the black screen show up and you see your reflection. You look like that. I will be able to reflect shapes over multiple axes. Multiple axes. We'll get to that. By the way, rest in peace to The Office being on Netflix. That will bother me for the rest of my life. Reflections. In lesson 1-7, you learned that a reflection or flip is a transformation in a line called the line of reflection. Now, what we're going to do is we're just simply going to copy the figure. It's already copied. And the given line of reflection, it's already copied. Then draw the reflected image in the line using a ruler. I don't have a ruler because I'm going to be honest, you guys. I'm going to keep it 100. Jesus is my ruler. Let's do... Thank you, Santi. Let's do one. Let's do 2 of them. Maybe we'll do all of them. If I'm going to try to draw... this is going to be a nightmare. So D is on the mirror. E looks like it should be around there. C is like boom, boom. Yeah, that's awful. Awfully good. Notice how the old C was up here and the new C is down here. If I were to do this, it's going to be weird. I'm literally taking my head and I'm tilting my head because I'm actually going to tilt my laptop. So I can draw Q looks like it should be there. R looks like it should be there. And S looks like it should be there. And T looks like it should be there. Boom, 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 boom. Awful. R prime, Q prime, T prime, S prime. And if you're wondering, like, why is it showing up down and to the right a little bit? First off, it's my awful ability to draw. Second, it's because my mirror is tilted. So whatever's up here is going to be reflected more down here. This guy, I'm going to tilt it again so that Z is like there. That's Z. Q is going to show up kind of, X, I mean, is going to show up there. Y there. W is there. Wow, is the lag super bad. Yeah, that just turned out awful. But it's a thought that counts. Algebraically, if you want to be lazy, you can memorize these rules. We did a problem in the warm up where we reflected it over the x axis, which means once was up is now down, and what was once down is now up. The x value doesn't change, the y value becomes opposite. So the way that we can denote that is if I'm giving you like a point, like I want you to reflect 3, 2 over the x axis, you could be like, okay, well, the x value stays the same, but the 2 value becomes the opposite. So my reflection point is going to turn into that. Similarly, if I reflect over the y axis, what was once on the left now goes to the right and vice versa. So the y value stays the same and the x value changes. This is brand new, and this is going to make sense. If I'm reflecting it over the line y equals x, and the line y, if I asked you to graph the line y equals x on that really easy coordinate plane over there, it's the most perfect diagonal line that you can ever imagine. That's the line y equals x. So your mirror is a diagonal. So once on the top left is now on the bottom right, and vice versa. The way you handle that is you just, if y equals x, then you just flip the y and the x because y equals x. So if the pre-image is xy, then the new image is going to be yx. All right? I. Thank you. Let's do a little bit of review and I'll mute myself. How's everyone's holiday break? Was it good? I never. All right, reflect this shape in the x-axis. The x-axis is this guy right here. So what this means is this shape is going to flip upward. You're treating this line as the mirror image. So since z is 1 unit away from the mirror, z prime is also going to be 1 unit away from the mirror there. X is 1, 2, 3 units away from the mirror. X prime is 1, 2, 3 units away from the mirror. Since y is touching the mirror, that means it's on the mirror, so y prime is going to be right there on the mirror. And what we have is a shape that is exactly the same, but flipped. It's a mirror image. And since it's the x-axis, once what was down is now up. Done. Reflect the shape in the y-axis. This one's going to be weird. The reason why this one's going to be weird is the y-axis is this line right here. So the mirror is actually cutting through the shape. So it's basically, if we were to take this piece of paper, fold it over and bring it back, what's left over here is going to be our shape. So let's take a look at z. Z is 1 unit away from the y-axis, which means z prime is going to be 1 unit away from the y-axis. X is going to be 1 unit away from the y-axis. X prime is going to be the same thing on the opposite side. Y is 1, 2, 3 units away from the y-axis, so y prime is going to be 1, 2, 3 units away from the y-axis.
And what you get is a mirror image on top of itself, since the mirror was in the middle of everything. Done.
Yes, all very exciting, Mr. Perich, but what does that mean for us today? Well, it means something very unique and different. You see, boys and girls, if you look at the problem does not reflect that John over the y-axis, nor is it reflect that John over the x-axis. It's reflected over the y equals -2 axis. The heck is that, bro? You're thinking. Mr. Parrish, the heck is that? The heck is that, bro? The heck is that? Well, if you forgot, and you probably did, the line y equals a number is a horizontal line. Y equals -2 is a horizontal line that goes through -2. Let me choose that. So my axis is going to be that line right there. All I did was, instead of having this line be my axis, now that line's going to be my axis. That's it. So when you do have pen and paper in front of you, and when you do have the notes in front of you, and you're able to do all these wacky, crazy things, you're going to pretend that that's my mirror. When I teach students how to do reflections, I always draw out the reflection line. I even did it in the warm-up. I drew it out. Even though it was there, I drew it out. Why? That's why. So now that yellow line is my reflection line. So how far away is that letter I from the mirror? Well, that letter I is on the mirror, so I prime is going to be on the mirror. How far away is that letter E from the mirror? It's 1 unit down, so it's going to show up as 1 unit up, and that's going to be my E prime. This problem is primed to not be as bad as I thought it would. I don't know what letter that is. I think it's an X, so we'll call it X. That X is 1, 2, 3 spaces away from my line of reflection. So I'm going to move it up. It was 3 spaces below, 1, 2, 3. So it's going to be 1, 2, 3 spaces above up here. That's my X prime. By the way, my X prime is the craziest X that I ever dated, right, guys? X prime. Q is 2 units down, 1, 2. Q prime is going to be 1, 2 units up here. That's my Q prime. Oh, wow, Mr. Perich, if you knew how to draw, what we would have is we would have the same exact shape that's just reflected along that yellow line. What are the coordinates? Q prime looks like it's 2, 0. X prime looks like it's 0, 1. E prime looks like it's -3, -1. And I prime looks like it's -3, -2. Oh, Cuckoo Kangaroo sent me my shirt. Looking at my email, Cuckoo Kangaroo sent me my shirt. Reflect and write across, write the coordinates of the image. I don't know. I must have wrote out coordinate the entire time. Now I'm doing a reflection across x equals -3. So if y equals -2 is going to be a horizontal line across -2, then it's fair to assume that x equals -3 is going to be a vertical line over -3. And if that is what you assumed correctly, boys and girls. Congrats to you. Now let's draw our lines out. Okay. Draw our points out. See that W? That W is 1 unit on the right side of the mirror. So W prime is going to be 1 unit on the left side of the mirror. See that S? That S is 1 unit on the right side of the mirror. So S prime is going to be 1 unit on the left side of the mirror. See that I? That I is 2 units on the left side of the mirror. So I prime is going to be 1, 2 units on the right side of the mirror. P is 1 unit on the left side of the mirror, so P prime is going to be 1 unit on the right side of the mirror, baby. Ooh, it's like an angel. It's like the letter X. So I have W. I have W prime, I have S prime, I have I prime, I have P prime. W prime, if this is 0, 0, W prime looks like it's left 1, 2, 3, 4, up 1, 2, 3. So W prime is left 4, up 3. S prime is left 4, up 1. I prime is left 1, down 1. And P prime is left 2, down 2. Not bad. And again, right now, if we were in person, this would be like the easiest thing that we've done ever on the planet. So trying to recreate this on like scrap paper is going to look ugly because you're going to have to recreate all of that, all those grid marks and straight lines, and it's just not going to look that good. I mean, you saw what I did with the first 3 problems. It looked awful when I didn't have the grid. So even when I do have the grid working on a Chromebook, it looks awful. I can't see you guys doing better though, so I don't know why you're going after me. So now I am to reflect across y equals x. Which is that line right there, that perfectly straight, not wobbly line. Wobbledy drop into my grave plot. What I'm going to do with this is I'm going to do exactly what the rules told me to. I could like turn my head sideways and be like, well, L looks like it's like 1 diagonal away, so L prime is going to be 1 diagonal away. And there's nothing wrong with that. That's perfectly fine. But I am not an artist, not in any way whatsoever. My brain is built for math, not for geometry, not for trying to draw pictures based off of weird diagonal maps or mirrors, I mean. So this is what I'm going to do. If I have something that's an XY and it's supposed to just flip, I'm going to write out my original points. So L looks like it's originally 0, 2. H looks like it's originally negative 2, 3. P, or I guess I'll go Q. Q looks like it was originally left 2, up 1, which is negative 2, 1. Is this the same shape as before? No, not even close. And then you have P, which is negative 3, negative 2. This is all you do. If Y equals negative X, I'm sorry, if Y equals regular X, then you're going to replace Y with X, so 0, and X with Y, 2. And so you should be able to look at that and say, you just flip them. So in the chat, so if I were to write what L prime was in the chat, I would type out L apostrophe prime to 0. While I graph that and get the others ready. Oh, whoops. I forgot to. Why did I hit? Actually, I hit enter. 0. Somebody type in the other 3. H is 3, -2. Thank you. Q is 1, -2. P is -2, -3. P prime, he said. Now time to poorly draw this out. Again, if I knew how to draw straight lines, you should be able to tilt your head sideways and say, oh, I see it. Okay. Type it in the chat what's going on here. Where am I reflecting this? Or unmute yourself. It's an axis. Which axis is it reflecting over? An obvious one. When something goes from up to down, good Santi, when something goes from up to down or down to up, that's a reflection over, or the way the book, or some books, the way the Principles of Algebra book likes to word it is reflect in the x-axis. I don't care if you say reflect over the x-axis. The x-axis is your mirror. Whatever. As long as you say that it's the x-axis as your line of reflection, that's all it is. And it's easy because, look, I mean, there's R, it's one unit under that line, and there's R prime. You're basically looking like, where can I draw a line that's literally in between those two? And it's the x-axis that's literally in between the pre-image and the image. Oh. Now, what we have to ask ourselves is, am I flipping up to down or left to right? Am I flipping up to down or left to right? Am I flipping up to down or left to right? Am I flipping up to down or left to right? And am I flipping up to down? So what I'm going to try to do is I'm just going to pick 2 points. How about F and F? And I'm going to try to figure out where exactly in between that would be. And it looks like that would be in between. Similar here. That looks like that would be in between too. So I'm going to draw that line. And so I'm going to say reflection. And in the chat, what was the name of a line that is a horizontal line? Is it x equals y equals, and what number would we use? See who remembers. Let's see who remembers. Let's see who remembers. Let's see who remembers. I think Santiago just mistyped and meant to say y equals, yeah, y equals positive 2. And the reason why it's y equals positive 2 is because when it's a horizontal line, it's y equals a number. When it's a vertical line, it's x equals a number. It's positive 2 because my line goes through positive 2 up here. Oh, it almost looks like a Star of David, does it not? It almost looks like the Star of David for all of my Jewish friends. Oh, I'll tell you what. I'll tell you what right now. It looks like it's the top view of a paper airplane. And it's not me going up to down. And it's not me going left to right. And it's not me going that way. This line of reflection is going that way. Well, the line that I just drew was y equals x. What that line is? That's a legit guess. Y equals x and x equals y is they're the same thing, but that's a good guess. So your thoughts of thinking reverse are a good idea, but maybe not reverse. Maybe a better word is opposite. It's not going to be y equals x. It's going to be tricky. So, I'm asking you to answer questions that you've never seen before. So, like, I do appreciate Santiago's guess because he had the right thoughts by saying x equals y. He knew that something was opposite, but it wasn't the flipped part that was opposite. It was the fact that, well, it's y equals negative x. And that might take us to the stunning conclusion of our lesson. Nope. Given quadrilaterals and his image, describe the transformation given the coordinate node. I'm not going to. Okay, I am going to. Given quadrilaterals, J, which is negative 3, 1. K, which is negative 1, 3. L, which is 1, 3. And M, which is negative 3, negative 1. Finally, I drew a decent shape. And its image J prime, which is 1, negative 3. K, which is 3, negative 1. K prime. J, which is 3, 1. L prime, which is 3, 1. And M prime, which is negative 1, negative 3. What's the line of reflection for that one? It's going to be a line. It's either going to be y-axis, a-axis, y. So far, the only ones we've done are y-axis, x-axis, y equals a number, x equals a number. And remember, x equals a number look like this. No, I'm sorry. X equals a number look like this. Y equals a number looks like this. Y equals x, which is a perfect diagonal, or y equals x, which is the reverse diagonal. Which is my line? What line am I doing here? Reflection in the what? Tilt your head sideways if it helps. There's my mirror. Y equals x is correct. I know what you said, but that's the same thing. All right, so in this picture on the right, what acts as the line of the reflection? That pond there, that lake there acts as the line of reflection. That lake. Wow, that was fun. I never realized that looking at my own reflection would actually yield positive things. I know a lot of us sometimes look at our own reflection and we hate what we see. But I want you to say, no. Now, after doing that lesson, reflections are beautiful. And when you look in the mirror, you have to realize that even though you might be ugly to others, or even though you might not like the way you look, maybe your face is all stupid looking, you have to remember that you are special, and there is somebody out there who likes you for you, and somebody who is going to fall in love with your face just the way it is, and they're going to love you and cherish you and hold you high. So before you're like, oh, I hate the way I look, I'm so stupid looking, oh, I'm so ugly, why did God make this freak? Why do I have to be cursed to look this terribly? What? The doctor, when I was born, instead of the doctor smacking my butt, they smacked my face because they couldn't tell the difference. When I was born, the doctor slapped my mom instead of me. Instead of doing that, realize that you have a gift, and that gift is you. And you're not ugly. You're not ugly. UGLY. You do got an alibi, and it's me, and you're not ugly. Well, that's it.